this. Who is I assume? Daphne, last time, actually, if you remember, uh, we were talking about one question, the triangle. The last question, I don't want to open this. I want to continue
Teacher,
from
teacher,
here.
teacher, teacher, I did it. I did that. I found it on the internet, the solution. My parents couldn't find it. My dad was like, yeah, I know this is a very known, like, hard question. So the thing is, you have to, like, draw one more, what do I call it? Triangle that all the three sides are equal to each other. And then if you draw one that's like staying in the side, it becomes an isosceles triangle, and then you capture like that part there and then the other part there, put one there, and then those two equal to each other, so you kind of find the degree from there.
Okay. But actually, also, I
Hard to
was
explain.
interested because on that day, idea didn't come. And I said, how come? This is just S1. S1 means for grade 7 students. And maybe actually, this is question 25, the last question. Usually, they ask one or two difficult questions. But I actually searched, I was also so interested why we cannot see that. I shared with my students. We solved in a lot of different ways, but I was not satisfied with the answer. Okay, the answer was complicated. And after that, I have one friend from Uzbekistan. He's also a math teacher at a special college because that is specialized in math. In Uzbekistan, there's one high school that's the best school in mathematics and physics in Uzbekistan. Yeah, he's a teacher there. He's my university friend. And he suggested one solution. I like the solution and I want to share it with you here. Okay. And there are a lot of different solutions, definitely. I always search, but it's good, but not so simple. Okay. So Ibrahim, Musa, Defna, just look carefully. I will do this. Okay. If you have any objection, then we will discuss together. And I will redraw this figure here. Okay. Because I want to do this separately. And that's our beautiful triangle. And we call this 20-80-80 triangle. That's a famous triangle. So now, and suppose that this side is something, let's say it is 8 centimeters. And we know that this ABC is an isosceles triangle. All right. And this angle is 20 degrees. And that means that this angle should be 80 degrees. Okay. Now I will draw the first line segment to this side. Okay. Such that actually this, let's say BD is equal to BC. I can draw this, right? And I'm just drawing in such a way that, all right, this also equals to A. All right, this also A. So again, also it becomes an isosceles triangle. So if it is AD, also this angle should be 80 degrees. If it is AD, and this angle should be 20 degrees. Musa, did you understand the first step?
Yeah.
Very good. Now I will continue. I will choose another point here is such that, let me just call this E. That's also equal to BD. All right. Let me just draw this. It's not drawn to scale, unfortunately, but assume that they are equal. So if I draw equal, this also A. Now also this triangle BDE becomes, what is it? Isosceles triangle. But we know that this angle B, it is 80 degrees, right? And this part we have already drawn. Here it is 20. Definitely, what is the remaining angle here? What is the measure of the remaining angle?
60 degrees.
Very good. It is 60, right? If it is 60, as you see here, ED is equal to BD. And also this angle must be 60. So if it is 60, and also the third angle, it must be 60 degrees, right? Because 60 also automatically third angle. What does it mean? It means that also this side must be A then. Okay. All right. I will continue drawing then. Okay. If it is 60, 80, right? This angle, we know that it should be 40 degrees. I will choose another point in such a way that actually this ED is equal to this. Let's say F. And unfortunately, it's not drawn to scale, but suppose they are equal, right? So now I will draw in such a way that that thing is equal to A. So if they're equal again, this angle must be 40 degrees. If it is 40, 40, this angle must be 100 degrees, right? Now this one is, let me just use a different color. This one is 60, it is 100, so the remaining angle must be 20. But automatically, again, as you see here, it becomes isosceles triangle. This is 20, this is also triangle. That means that this should be also equal to A. Actually, this part, right? This part should be also equal to A. All right, that means that actually if I join this, exactly, actually, it will be joined to this point. What does it mean? If it is 20 to 20, then this angle must be 140 degrees, right? So what is the question here? We need to find the angle BDA, right? So to find this one, I will join another line from here. Let me just join this with a red line, okay, from here. If you just join this, okay, as you see here, this side is equal to this side. It doesn't look equal in the picture, but if you draw with a ruler, you will see they are equal. That means that this angle is 160. So this angle should be 10. And also this angle should be 10. So then what is this x? This x is equal to 140 plus 10. That's equal to 150 degrees. Definitely. Did you understand? The last part is easy. Just I'm drawing equal line segments. First, I jump with this, okay? Again, the equal line segment, okay, put your ruler, measure here. And after that, again, equal line segment, join here. But you will see that the third one will overlap at this point here. Okay, here I
The
have
way
joined
that I
actually
learned
here.
was easier.
Huh?
The way that I looked it up was a little bit more easier to understand. Like you didn't have to
Yeah,
do that
maybe
much
for you, maybe
calculations.
different solutions are easy, but for me, that is the easiest way to solve, I mean, for this question. Because other
It is the
solutions, I
easiest way
didn't
to
find them easy.
understand the question, teacher, but not like I don't think the easiest way to solve.
Huh?
It is an easy way to understand what the question says or how can you solve it, but not like an easy way to solve it maybe.
No, I'm approaching, for example, this is for grade 7. Using trigonometry also we can solve this, but actually for grade 7, they didn't learn trigonometry yet, right? And for example, similar triangles, also they didn't learn it yet. You learn this in grade 8 and 9. But actually what I do here is everything is taught in grade 5 and 6. I'm just using very simple idea here. No any similarity, no congruent triangles, or no trigonometry here. Just drawing line segments. I just draw 2 line segments. Number 1, choose one here. Let's say here. So this should be 20 and equal. So that means that this angle will be 80. Also, this angle will be 80. So that means that this angle must be 20. And I will choose another point from here and just join them. And equal, actually. I'm just drawing equal line segment. But here, since this angle is 60, also this must be 60. That forces that also third angle must be 60. That forces that also this side should be equal to each other. Now, again, if I just join this, all right, you will see that also this will be equal to this. So which means that actually this angle is 140. And from here, this angle is 10, this angle is 10, and that is 20. So that is 140. So together, 140 plus 10, that's equal to 150. Okay. And sometimes maybe, if you just have a look again, you will say that just draw on the paper one more time yourself. You will see that this solution is very easy solution. At least for me, I compare other solutions. I found this one the easiest way. That's why I explain using this method. All right, guys, I'm closing this. We will continue with S2.
So 20 plus 20 40 minus 180 40, 140.
Yes.
That's easy way, yes.
If you draw on the paper, yesterday night it just came actually to my mind, and after that, okay, and I got it, and I just woke up. It was about 12 o'clock. I went to my table, draw this. I got the answer. I said, okay, now I can sleep.
Teacher, the
Because
same thing happens to me sometimes. It's there's a question I need to answer, and I'm at night, I can't go to sleep. I have to do this.
Yeah, because on that day we tried, and also it was so, I was, how come, how to say, I was not so satisfied, with my solutions. I thought a lot, how come they're very easy? There must be easy way. And actually I thought about this question like maybe 2 days, and I got some answer, but still I was not satisfied. And after I found this answer, I said, okay, that is the easiest way. And that's why. Anyway, guys, let's
Sure.
continue.
Can I ask something? Which
Yes.
date exactly will this math Olympiads take place?
Which day? I think it's mid-April, but about the exact day, definitely, I'm not sure. We can ask
Cause
Mr.
like
Adalat.
they,
He knows because he's the one who's organizing this, and
I
they set
know,
the date. That's why I don't know.
like he personally said like that we should be forming like they filled there are so like registers there, but not like actually chosen yet. But I think there was like this sort of rumors in our school like our teachers were sort of talking that it was going to be end of the February and stuff. But
This
I was
end
like,
of the
it's going
February,
to be
it's a mock
later.
exam, right? Mock examination.
What is that?
Mock means it looks like a real exam, but it's not real.
Hmm.
It's like a warm-up exam. Okay, just it's not a mock
Okay.
examination means it looks like real exam, but it's not the real. It's not an official one. But official one will be in April.
Okay.
But this test, you will just see actually what does it look like. Okay, what kind of question will come. All right, and what is your level so far. Okay, just it's like warm up. Let's say warm up exercise.
So how are we going to take that test? Like from online, right?
Yeah, I think so. At least for February, but April, I don't know what's the situation. If everything okay, you will have exam physical in the classrooms. If quarantine continues, it will be online, I think.
That's sad.
Okay, right now we don't know what happens, and okay, Musa, Ibrahim, Daphne, and also Sona, she's now here. So we practice S2, S1 questions. Now, today and the next our class this week, we will practice S2 questions. Now you will see that a lot of questions are similar, but now a little bit more, I mean, not complicated, a little bit harder. Okay, so here we have 25 questions. Actually, you should try to solve every question in less than 4 minutes. Okay, anyway, so we have already seen this question, right? The first day of 2014 was a Wednesday. There are 365 days in 2014. And what day of the week will 2015 begin? All right, if it is Wednesday, so 2015, it will be Thursday. Very similar question. And the next question, what is the maximum number of parts that can be obtained from cutting a circular cake using three straight cuts? And also we have done this already, right? Three cuts, how many? It is 8, right? We just cut one from here and one cut from here. Maybe we can just take now 4 pieces. We can make one more cut, or I can just cut from here, right? So the how many parts we can make? 8 parts with 3 straight cuts. I mean, we did these questions before. That's why I'm just going to do like 4 or 5 questions together. After that, I will ask you to give a try. And how about this question? How did we solve this? Evaluate, right? Sona, are you here?
Oh yeah, yeah. Hello. I've been here for like 5 minutes now.
Okay, Sona, just give me an idea. After that, you can have a rest. Okay, what do you think? How would you solve this question?
So first, of course, we do the multiplication, and
No,
after doing the both
no,
sides, then we subtract the answers. Why
no.
not?
How do you multiply 2014 by 2014? How?
Just do the last dials.
Just like multiply them. What do you mean? Like how do you multiply it?
It
No,
takes
just
a long.
multiply the last one, like last digits of both, and you will
Okay.
find the last
The
answer.
answer
And
will
then
be
they,
one.
No, 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 no. Look, in this
Yes,
kind of
it's fine.
questions, you need to use
am I right,
algebra.
teacher?
All right. Let's say x is equal to 2014. Then what we have here? Here we have x times x minus, what is 2013? It is x minus 1. And how about 2015? It is x plus 1. If you simplify this, x squared, x minus 1 times x plus 1, that is x squared minus 1. So that's equal to 1. If
But
you try to
like,
multiply
if
this,
we use the same way that I use, like it will be the same. Like I got one as well.
You can
very
just
good.
take the
How
average
did you
of
do
those.
that, Sona?
So first I multiply 2014 and 2014. It will make like a number at the end. It will it will be a long number, 4,056,196. And then after that, 2013 multiplied by 2015, that's gonna be like 4,056,195. So 96 and 95, one difference. So the answer
Yes.
will be one.
Sona, but to do this one, how many minutes does it take? But this one, we just did this in 10 seconds.
Teacher, you can also do the way that I did.
Still.
You can just multiply the last digits, like it will be 16 and the other one will be 15.
Yeah,
So-
exactly. Like we can make the multiplication shorter.
Yes. But teacher, your way is a lot easier.
No, no,
I
no.
mean,
Actually,
yeah,
I
we
can
can
show
use
you some
both
more
ways.
examples. Okay, Shamurga, this is a very simple example. If I just add some more numbers, definitely, Sona, your method does not work. Because maybe here we have only two. If you have a fraction and these numbers are different numbers, you will see that your method will be very complicated. But usually general way is to solve this kind of question in the fastest way is you have to introduce some variable. It becomes an algebraic expression, simplify this, and after that, evaluate its value. That is the fastest way actually, without using a calculator. And Sonny, you are saying that 4 million something something, it takes a lot of time. You should solve this question maybe 20 seconds.
Yeah, it's just like the first method that came into my mind. That's why I told that.
Okay, good. Guys, anyway, I suggest
Can't
it to
we
use
like
algebraic way
divide
into
them
the
all
variable
onto
and
something, teacher?
say again.
Can't we just divide them all to like something that they all divide, that they can all divide into, like, I don't know, maybe two or something like that.
Yeah, there may be
And
some
then like,
different ways, but usually, Daphne, this kind of questions in general, what do we expect from the students? Can they use algebra to solve this in the fastest way? That is our expectation. As a teacher, when we are preparing questions, that's the expectation. All other different ways, it takes much, much longer time than using this method. You can try this. It takes much, much longer time than this. But the shortest way is to use algebra to solve this problem if you're not allowed to use a calculator. Okay, let's move on to the next question. And also you are familiar with this question, right? It just goes to infinity. That means that if the whole thing is equal to 3, also here inside starting from here, it should be equal to 3. That's equal to 3, right? If you square both sides and solve for x, what is x? X is equal to 6.
6.
All right, good. And also we did this before, 1 minus 0.999. This goes to infinity. If you just change it into fraction, that's equal to actually 1. So that's equal to 0. So the answer here is 0, right? Okay. Next question. And also we did this before, I think. Let's also do this together. And after the starting from 7, first you give a try, and after that we will discuss together. Mersenne primes are prime numbers of the form m subprime is equal to 2 sub power of p minus 1, where p is a prime number. For example, 3 2 square minus 1 is a Mersenne prime. Find the fourth smallest Mersenne prime. Anyway, and just here, by asking this question, they are introducing you with this kind of special number. Okay. And it's from number theory. So it says that Mersenne primes are prime numbers, right? So of the form where p is a prime number. So now if you just check this, for example, okay, the first one is, right, if it is 2, what is it? 2 squared minus 1, 3 is prime. Okay, that's the first one. And how about if the second one is 3, the second prime number, 2 cubed minus 1, that's equal to 7, 7 also prime number. That's the second smallest one. How about the second next
But
prime
what
number? It
about
is
5?
5. 2 to the power of 5 minus 1, that's equal to 31. It's also prime number. And how about m7 to the power of 7 minus 1? It is 127. Is it also prime number? Yes, right? Because it's not divisible by 3, it's not divisible by 5, it's not divisible by 7, right? So the answer is, the fourth one is 127. All right, guys, next question is for you. Okay, give a try. After that, after 2.5 minutes, we will discuss. Oh, we did this before. Sona, this question is for you. What is the answer?
Is it a 0?
Yeah, because here is a kind of trick anyway. Here we have A, B, C, D in alphabetical order. After some letter, we have also X. X minus X is equal to 0. That's why the answer is 0. How about this question? Give a try. Okay. If you know, you can just write your answer to the chat box. After 2.5 minutes,
We can't write
we'll
them
discuss
into
together.
two.
Huh?
We can't divide them into two, right?
What do you mean?
Like we can't make 4 out of the smallest square, like 4 squares out of that. We're always imagining that, right?
No, here the question is how many squares are there in a 5 square grid? Means how many squares can you see? For example, number 1 by
I
1,
know,
how many?
like
25. How about 2 by
sometimes
2?
in certain questions, teacher, like you do all the squares and stuff, but then it says like, well, we didn't say you can't like draw like lines there to make a smaller square.
Definitely, I didn't get you. Can you ask one more time?
Divide like one square into like 4 smaller squares, right?
Okay.
Sometimes in like a question that I did, it was similar to this, like, and it says extra, like you do the all stuff and you find how much squares there can be, and then they say like you can do this much actually. The answer is like a lot more, and then they put it there. We didn't say you can't like draw lines and stuff, so
Hmm.
this is not one of those, right?
No, no, no.
Okay.
It's like, for example, let me just ask one similar question. Okay, here, very simple question. Let me just write like this. Okay, here we have. If I ask you the question, how many triangles are there here? For example, let's say this point is A, this point is B, this point is C, this point is D, this point is E. How many triangles can you count here? Number 1 is ABC, one triangle, right? ACD, another triangle. ADE, another triangle. How
It can
about
be switched there, teacher.
ABD, another triangle? ACE, another triangle, right? And ABE, another triangle. Do we have any different triangle here? So how many? 6 triangles here. Who is answering here? Ibrahim, 17. Ibrahim, how come is it 17? Here we have how many squares are there in a 5 by 5 grid? Here at least we have 25 squares, right? At least. Look, here we have how many squares? Can you see now? 25
38,
1 by 1 squares, right? Musa?
38,
No.
more than 38.
More than that, yeah. What I suggest you here is, can you count how many 5 by 5 squares we have here? How many 4 by 4 squares do we have here? How many 3 by 3 squares we have here? How many 2 by 2 squares we have here? how many 1 by 1 squares we have here. And just sum them up and we will get the total number of squares here.
Is it 55?
55. How did you get this? Sona, how did you get 55?
Sure, I found. Yes, I found 30.
30?
Yes.
Come on, Daphne. How many 5 by 5 squares do we have?
Oh no, 5 by 6. 1.
1. And how about 4 by 4?
4.
No.
Yes.
This one is from here to here, 1. And from starting from here to here, it is 2. And this one is 3. And this one is 4. If you just go the same thing down, right? Also, we have 4. How many? We have 4.
4 by 4, not 2 by 2, teacher.
Oh, 4 by 4. Yes, 4 by 4. Sorry. This one is from here till here, right? It is 1.
Yes.
And
4.
also starting from here, we have another one,
Yes.
2. And down way, it is from here till here, it is 1. From here,
A little bit
sorry,
down.
until here, and here we have 2. So altogether, we have 4.
No, teacher, you should do the other side too.
Yeah, I mean, from here, actually, I'm talking about this one. This one is 1, right?
But you have to multiply them because, teacher, you can do like one like that and the other way, and then go down
No.
one level and
Look,
do
this
another
one,
2.
this one is 1, right? This one is 1.
Yes.
Another one is, if I start from here, for example,
Yes, like that.
this one, another one, right? 2.
Yes.
So if I just move 1 unit down, again, we will have 2 more here. 1 more is here, right? And 1 more is starting from here.
That is
So
what
how
I'm saying,
many?
teacher. You
It
have
is
to
4.
like multiply those like lines that you drew.
Daphne, are
How
you
does it
saying
look
that we
like
have
one by
more than
one?
4 by 4 squares?
No. I'm just saying like you have to multiply them, but you like just draw, we're going to write 2 there. 2 there and then 2 the other side. So 2 in that level and then 2 in the other level. So we have to multiply them.
Multiply what?
Never mind, teacher.
Okay. So here again, if you just count 3 by 3, here we will have 9 such squares. 2 by 2, it is 16. 1 by 1, 25. So the sum of these numbers, 1 plus 4, 5, 14. What is it? 5, 14. It is 30.
55.
So altogether, 55 squares. Okay.
Mr.
Let's move to
Kasem,
the next
anyway,
question.
if you just like
Teacher,
multiply
30.
5 by 5, 4 by 4, 3 by 3, like if you squared each number, you could have just gotten 55 anyways.
Yes. But teacher, I found like the number of them without like the 25 single squares. That's why it became 30.
Okay. But at least here, definitely you should understand the idea. Sometimes, for example, let's say instead of this one, maybe they can just put like this. Maybe the middle part is empty, or maybe this one is empty, for example. Okay. But what I'm saying here is we should just count this in a certain systematic way. Okay, first count 1 by 1 squares, after the 2 by 2 squares, and 3 by 3 squares, and 4 by 4, then 5 by 5. That is the fastest way to get the total number. But this one is very easy one. If they change a little bit at the time, if you use this method, you will reach the solution much faster. Anyway, guys, let's solve another one. How about this one? Can you try once again? You have 2.5 minutes. After that, we will discuss together. And we did a similar one already. Sona, do you understand this question? Do you remember? Ibrahim, how about you?
Oh, I finished.
You finished. Can you write your
Yes,
answer
but
in the
I
chat
got two
box?
answers. What?
Can you write your answers in the chat box?
Yeah, sure. Should I send you privately or like to everyone?
Yes, privately.
Okay.
Sona, how did you get it? Did you guess yes, or you solved this as an equation?
Oh no, I solved it as an equation.
Very good, very good. How about
I
Defna,
see how
Musa,
I did it.
Ibrahim?
Mm, I don't know.
Sure. I don't think there's a possible way to like do it.
Is my answer correct?
Yes, Sona, your answer is very correct. And if you solve this
Okay.
in the algebraic way, that's cool. And as you see here from the picture, I mean the equation wise, actually the nature of this equation suggests that we can factorize the left hand side. How? Here we have x squared minus here we have 2y squared, right? On the right hand side, 41. And also we know the 41 is a prime number because the only way I can factorize 41 is 1 times 41. Now, if you just factorize the left hand side, here we have x minus 2y, and here we have x plus 2y. On the right hand side, 41. And the difference of these two numbers and the sum of two numbers, right? The first number is x, what? And the second number is 2y. So since we are talking about, what is it, positive integers, the difference of two numbers is always less than the sum of those two numbers. Always, it's positive. So that means that since 41, I can only write it as 1 times 41, x minus 2y must be equal to 1. And x plus 2y must be equal to 41. Now, if you solve them together, add them together and divide by 2, x equals 21. If x equals 21, what is y? Y is equal to 10. Okay, Musa, Defna?
I can't find. Yeah, I have the same like way, but I wrong at like.
But did you factorize like this, Musa?
Yeah, I thought it was like this, but I didn't know that. Oh, that's wrong. Like x minus 2y equal 1.
Good. Because here it says positive integers. And that's why the only way is the smaller number must be equal to the smaller number, and bigger number, x plus 2y, must be equal to bigger number. We have no any possible answers if they are in positive integers. If not, of course, it has infinitely many solutions. Okay, guys, let's move to the next question. Now, at least you get some idea. Find the dimensions of all the rectangles with integral size whose area and perimeter are numerically equal, right? If you remember, we already did this question earlier and we got two answers, right? This one is width and this one is length, right? And what is the perimeter? Perimeter is 2 times width plus length. And how about the area? It is width times length, right? So numerically equal means that, what is it? We know that the area unit is, I mean, perimeter is centimeters. This one is square centimeters. We are just ignoring their units, right? The numerical parts are the same. And Daphne, do you remember what answer did we get for this?
May I? I know the answer.
Yes, tell me.
Oh, so the first one is 4, 4, and the
Okay.
second one is 3, 6.
3, 6, right? That's it. This
Yeah.
one is width, this one is length. We have only two answers. Very good. Let's move to the next question. And also we did this before, but first just give a try and after that let's discuss together, okay? 2 minutes.
I found the answer.
Well, Sonia, you have answer?
Oh, yes, I do. I found it.
What is it?
I got 58.
58.
Yeah.
Daphne, how about you?
Sure, I don't think I didn't get anything. Like, I got something, but I know it's not true. It's not correct.
But Daphne, last time when I asked this question, you solved this question correctly. You remember? We couldn't solve it, but you solved this.
I know, teacher.
A whole number is between 40 and 70. Okay, that it means how many numbers we have here? Only 30. When it is divided by 3, let's say that whole number is, let's say it is A. It is between 40 and 70. When it is divided by 3, the remainder is 1. So that means that when we divide by 3 and we have quotient here, the remainder is 1. And when it is divided by 7, right, 7 times q, a quotient is something, the remainder is 2. Find the number. So that means that just we need to check the numbers, right? Using the bigger one is 7, right? So what is the number between 40 and 70? When we divide by 7, the remainder is 2. Number 1 is 44, right? 44 is equal to 7 times 6 plus 2. But if you divide 44 by 3, right, it is 3 times, what is it? 14, right? And also the answer is, what is it? 2. But actually the remainder must be 1. So it doesn't work. And the next number is, what is it? 50, 51, right? 51 again. If you divide by 3, 3 times 16, or 17, right? Actually, 3 times 17, the remainder is 0. It doesn't work. Next number is 58. That is 3 times 19 plus 1. And 58 is 8 times 7 plus 2. If you divide by 7, remainder is 2. If you divide by 3, remainder is 1. So what is the answer? The answer is 58. In different way we can find this, but this is very simple question. All right, just 40 and 70, and just guess and trial method. Okay, sometimes also guess and trial method is much faster method. Ibrahim, it is 58, right?
Yes, sir. I missed my number.
Good. Okay, guys, let's move to the next question. And how about this with a similar question? Can you give a try again? 2 minutes.
I finished, but I got an answer, but like I'm not
Okay, Sona, can you write your answer to the chat box? So we have 27 seconds. Okay, after that we will analyze together.
okay.
Musa, how about you?
I don't know. I found the like 1 7 of x, like
Daphne, Ibrahim, any answer from you?
Is my answer correct?
I don't know.
It should be.
I hope so. Okay. Right, let's do it together. Sona, your answer is 1/2. Let's see. Again, actually, the idea is very simple, right? It goes to infinity. Just we need to see the pattern, right? Let's say the whole thing is equal to x. Then here we have 2/2 plus 12, right? As you see here, it is exact copy of the original question. So that also thing should be equal to x. On the right hand side, we have x. Now from here, actually I can just write it as what is it, 2/2 times 1 plus 6x, that's equal to x. This 2 is gone, right? And if you take this to the right hand side, here we have x. uh, Let me just actually multiply at the same time. 6x times x, 6x squared plus 6x, and here we have 1, take to the right hand side, minus 1 is equal to 0. And we need to solve this. And if you factorize this, 3x and 2x, if I just multiply, it doesn't work because the sum should be 6. Is everything all right? 2/2 plus 12. It is x. The whole thing is equal to x. And 2 divided by 1 plus 6x, 6x squared plus, oh, it's wrong, right? I made something wrong here. So this one is 6x plus 1 times x is equal to 1. So from here, 6x squared plus x minus 1 is equal to 0. So that this one is 3x times 2x. This one is, it is plus, so it should be minus 1 and 1. If you cross multiply 3x minus 2x, that's equal to 0. From here, 3x minus 1 and 2x plus 1 is equal to 0. So what is x? 1/3, or x equals minus 1/2. But this answer is always plus, right? 2/2 plus something. 12 times 2/2 plus something. It is positive, so it cannot be negative. So what is the answer? The answer is 1/3. Okay, so now where did you make a mistake? Maybe when you're factorizing this.
No, like in the beginning when you wrote 2/2 plus 12x, I wrote it 1/. I didn't write 2. That's why.
Um,
That
okay,
when I did that, like my
I was so close.
calculation changed. But like
good.
I was.
All right. So Musa, did you get it?
Yeah, I was so close to it.
Very good. Okay, good. At least you got the idea as I practice more and more questions. But again, also after we finish this, if possible, you need to practice these questions again. If you can solve this, that means that you understood 100%. But still, if you're stuck somewhere, that means that you need to practice more. Guys, how about this question? Let's solve two more, 14 and 15. Okay, after that, I will finish the today's class. And let's do this together. Shall we do this together, or you want to try this? Okay, first give it a try. Okay, then let's discuss together after that. We have 2.5 minutes, and after that we will discuss it.
Sure, these are like odd numbers, right? It goes by like odd numbers, not by like.
Yes, these are odd numbers: 1, 3, 5, 7, 9, 11.
I have no idea how to do this because I don't know what way I should use. So I'm really confused on this question.
If I just ask you, Sona, write this one like this: 1 over 2014 plus 3 over 2014 plus 5 over 2014 plus dot dot dot. Sona, can you just tell me the last three terms of these numbers? Of course, denominators are 2014, 2014, and 2014. And the last one is 2013, right? Before 2013, we have here 2011. Before 2011, here we have 2009. Is that
Can you
right?
repeat? Your voice lagged.
Really? Musa, can you hear me well?
I can hear
I
you.
don't know. My Wi-Fi is very slow, and I don't know.
How
Like,
about Defna? Can you hear me well? I mean, the problem is
Yes,
with
I
my
can hear you very
interconnection
well.
or? Yeah, okay. Okay, Sona, can you hear me now?
Oh yeah, my Wi-Fi is very slow for some reason. That's why your
Yeah, I
voice
know.
lagged.
Usually, I don't know. In Azerbaijan, I think there's an internet connection problem. Up here,
Yes,
our
the internet is not good. Even if it's good, like half of the stuff are just like blocked for
I am
some
using
reason.
LTE right now. With LTE still, it doesn't work properly.
okay, because here our internet connection is very, very good. I mean, compared to a lot of countries, I mean, my internet connection never lags. It's always good. And that's why if something is wrong, it's because of your internet connection, not because of mine. Anyway, guys, no problem. Sona, here I just wrote the last three terms, right? It's just continue like this. Now, if I just pair numbers like this, first one with the last one, what is their sum?
We should add the denominator or
Yes,
numerator.
numerators,
Oh,
right?
okay.
What is 1 over
Okay.
2014 plus 2013 over 2014? What is the sum?
2014, 2014.
What is it?
So it's
It
gonna
is
be
1,
like,
right?
yeah.
Okay.
So
So the first one and last one, their sum is equal to 1. And the second and second from the last, also their sum is 1. And the third and third from the last, also their sum is 1. Do you understand? The
oh, okay,
question
yeah,
is,
I get it.
how many
Yeah.
ones do we have, guys? Now, can you continue and tell me the answer? Because there's also another tricky point here. Let me see if you can finish it or not. Let's tell me your answer. What is your answer then?
2.
What should we do now?
Yo, I just give you hints. Okay, now can you calculate this? What is the sum?
$1,007. 1007.
No.
Is it gonna be 2014?
Okay, because there's one tricky point here. If I ask you another question, how many fractions do we have here, Musa? Can you tell me?
What? I can't hear.
How many fractions do we have here? 1, 3, 5, 2009, right? How many fractions do we have here? So actually, how do you find this? The last number is 2013. The first number is 1, and the amount of increment, it is 2, right? Because we are just adding 2 and
2014.
add 1. So that's equal to 2012 over 2 plus 1. That's equal to 1007. So that means that here we have 1007 fractions. It's not even. Okay. So what can I do with this? I mean, to do this one now, I will just do like this. Look, here I can actually pair the first one with the last one, right? First, I need to find the fraction in the middle. What fraction do we have in the middle? Actually, here in the middle, we have 1007. Actually, not 1007, right? Is it 1007? Yes. 1007 over 2014. This actual fraction does not have any pair because it's in the middle, right? And other fraction, the first one and the last one, second one and the second from the last one, right? The year sum is equal to 1. How many? We have 1006, right? So the sum is equal to 1006 plus, in the middle, here we have 1007 over 2014. So what is the answer? The answer is 1006 and 1007 over 2014. That's the answer. Okay, Sona, did you understand?
Yeah, yeah, I
Yeah.
was so cool.
Okay. Guys, then that much is enough for today. And I will save and maybe share with you. Okay, if you have a time, you can look at other questions so that if you get
Again.
ready and come to the class, it will be great. If you're too busy, we will see. Okay. Thank you very much. I will see you. I will meet you on Wednesday. Have a good night. Okay. All right.
Okay, thank you. Goodbye.
Thank you.
Good
Bye
Bye.
luck.
bye.
Bye,
Goodbye.
teacher.
Bye bye. Thank you.